Welcome back to the math path. I have come up with a wonderful way of explaining numbers, what a number is, because we didn't do that great of a job before. Now look, so get out of the way. So before you get to numbers, you have just, you can call them counting numbers, I guess. It's just things that are in order. It's ordinal numbers, you know,
funny.
1, 2, 3, 4, 5. You just count them. They go in order. That's the only thing you can say about them. One is first, the next one is second. Okay, so let's say, now you can do, like I said, a lot of things with that. You can do arithmetic. So let's say you're walking along, like I'm walking along, and you're taking steps, and you can say, okay, I just took however many steps, 2, 3, 4, 5, 6, 7 steps. And then you know, you can also have rows.
With the red shirt.
Hello, homeschool group people. You can also have rows walking. Okay, rows, do some walking. Do some here. I'm gonna go. Wait. Stop. I'm gonna go in front of you so we can actually see it. Okay, walk so happily. Walk happily. Why are you walking grumpy? I don't even understand. Okay, so wait. Now stop. So you can, even with those, just like the two lines that you don't, before you have any concept of numbers, you can add them together or whatever by taking your compass and using it as a transfer and putting one line by the other one. Just so, here, come back, Rose. Come back, Rose. We're gonna do it. Okay, come back, someone who will listen to me. We're gonna do it with steps, okay? So, here, grab onto me or something. Okay, so we're gonna go, or stand at my feet, okay? So you can take and add them together. You can say 1, 2, 3, 4, 5 daddy steps, and then now Annabelle, you take 4 steps forward in the same direction. Okay, stop. So there we go. We added them. It's 5 daddy steps, 4 Annabelle steps. What else can we do? We can't do anything because they're incommensurate with each other. They're incommensurate. They have lots of problems. We don't know the relationship between the two. The one is not measured by the other, and they're not measured by anything they have in common. So they're just steps. Now, at some point you could say, okay, we're going to take the king's foot and we're going to make that a standard step, and then everybody gets rulers because you have mass production, and you get interchangeable parts, railroads to Africa, everything, all because of numbers. Prudently, logically, discreetly. Numbers are discrete units invested in your brain. To be specific, in the brains of you and me. Here, I need to hold onto your hand or something, but I'm holding this baby too. Okay, there you go. And there's in discrete numbers. There's not an infinite number of numbers. There's no such number as a little bit. Sorry, Newton, there isn't. There's no such number as a lot, a whole lot. There's definitely no such number as forever and ever. These numbers they're not numbers. They're concepts, I guess, a little bit. You can have a little bit, but you're not measuring it. Once you measure it, then it could be a number. So here, if you try to do a real number, like in this interval, what's between the interval between these two boards? Nothing. You just fall into the creek of despair and illogic and endless torment. So don't do that. You have numbers. You can make them indefinitely small. You could, Google is a number. Googleplex is a number. one Google plexith is a number, but I mean, there's just limits. You can only measure so accurately, right? And you can't go beyond the limits of your measuring devices. If we're going to actually measure things, mathematics is the science of measurement, we have to remember. So, you know, if you want to, we were talking about calculus, you want to do really complex, whatever, derivatives or something, you can't measure. I mean, can you really measure x to the fifth or whatever? Do you have a good enough stopwatch for that? And you can't measure a speed over an instant. There's always an interval. There is no instantaneous speed. That's a nonsense concept. So anyway, let's stay accurate, stay cool. That's what makes a number, is that you measure it in terms of the king's foot or some kind of unit. And you can't, I had lots of thoughts, but they're very disorganized now due to, I don't know, but you can't measure a smell in terms of your eyes. You can't measure a color in terms of your nose. Your nose can't measure a color. You can't measure pi with straight lines. You can't measure a curve with a line, by the way. They're incommensurate. There's lots of things you can't measure with each other, and some things that you can. Okay, so I filmed the analogy quite well, but I didn't really, I feel like, explain it very well. So I'm gonna go through a little bit more systematically. So the ladder to numbers. Oh, here, let's start from the bottom and we'll go up. So you start with stuff you can't even quantify at all. Like, you couldn't quantify happiness. I don't know. Ask Mises. It's not like you can't, and you certainly can't like multiply your happiness. You can't even really exactly quantify. Am I happier than you? How much happier? I don't know. So that's unquantifiable things. Beauty would be something perhaps it could be and theoretically quantified. So we'll take the first step, because at least it is extent in the physical world and not just endomorphic, introspective. And then you can get to things that are quantified, are quantifiable. You can quantify them for sure, like our steps, okay? But they're not a number yet. They're a quantity. They're quantity until you add units, okay? Units that you can measure precisely things with. So once you have a unit, like a Tesla or a joule or a pound or whatever, then you can measure things in terms of that, and then you have a number. So there we go. That's what it's all about, and that's why a number is a ratio, because you always have a unit. A unit keeps it anchored to reality. We have it anchored to reality by having actual physical little metal discs, but you can anchor it to reality in an abstract way also by just having your unit be another quantity. It doesn't have to be specific what that quantity is, because they all act the same way, whether it's a pound or whether it's a wavelength or whatever. It's that's the magic of math.
This is a girl. She knows calculus. She knows how to do everything. I only do. No, she does not know calculus. No, she doesn't. She doesn't. She doesn't. Do you want your 2-year-old to do calculus? Watch this video. The magic of math.